Okay, in this video we're talking about experimental versus theoretical probability. Okay, so theoretical probability is the probability we've been talking about. It's what's supposed to happen. So if I roll a die and it's a regular six-sided die, then every 6 times I roll it, theoretically I will get 1 1, 1 2, 1 3, 1 4, 1 5, and 1 6. Now, we all know, we've all played with dice before. We know that that hardly ever happens. So we have, besides theoretical probability, there's also what we call experimental probability. And that's what actually happens when an experiment is conducted. So in other words, if I roll a die 6 times, what do I actually get? So let's look and see on this one. So the first time I get a 6. Next time, I get a 2. The next time, a 1. Fourth roll gives me another 1. Fifth roll gives me a 4. And my last roll gives me a 3. Okay, so theoretically, I should get a 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. I was actually pretty close to that. The only thing I'm missing is the 5, and instead of a 5, I got 2 1s. So, experimentally, the probability of getting a 1 was 2 times I got a 1 out of 6 rolls. So, even though theoretically it should be 1 out of 6, this time when I rolled, it was 2 out of 6. The probability of getting a 2 this time was 1 out of 6. The probability of a 3 was also 1 out of 6. The probability of a 4 in this experiment was 1 out of 6. But the probability of a 5, I didn't get any 5s. So that is 0 out of 6, or just plain 0. And the probability of rolling a 6 in this experiment was 1 out of 6. Okay? So the experimental is just based on what actually happened when you did it. Okay? Now, we're going to do that again. I'm going to roll 10 times this time. I got a 1, a 6, 2, 5, 1, 4. There's 6 rolls. So 4 more. I got a 2, another 2, 2 more rolls. I get a 6, and another 6. Okay, so let's get the experimental probabilities again. The probability of rolling a 1 in this experiment, I got 2 1s, so that's 2 out of 10. Probability of getting a 2, I got 3 2s, so that is 3 out of 10. Probability of getting a 3, I never got a single 3, so that is 0. Probability of getting a 4 was just 1 out of 10. The probability of getting a 5 was also just 1 out of 10. And the probability of getting a 6 was 3 out of 10. Okay? Now, I can use these just like I used in the to make predictions before, to make estimates on what would happen. I can do the same thing with experimental probabilities. Right? I can make a guess on what's going to happen based on this, just like we did with our random samples. So let's say I was going to roll 100 times. I could take a guess if I kept rolling this die 100 times, so 90 more, about how many ones I would end up with. Right? I would guess, since it was 2 out of 10, then I'm going to guess that that would be somewhere around 20 out of 100. All right, multiply by 10, multiply by 10. That would be my guess. It's probably not going to be exactly 100 or exactly 20 out of the 100, but my guess would be somewhere close to there. If I kept rolling the same die and I wanted the probability of getting a 6, since it was 3 out of 10, I would probably guess that is going to be close to 30 out of 100. Now, the only one, and this is where you got to kind of be careful, and you got to think a little bit. I didn't get any 3s. I highly doubt if I roll 90 more times that I'm going to get 0 3s. So even though for this one it was 0, if I wanted to make a prediction on how many I thought I was going to get out of 100, I'm not going to say 0. It's probably going to be low, but I would imagine 90 more rolls, I'm probably going to at least get a couple of 3s. So you do have to kind of be careful that way when you're making your predictions. So let's look at one more. I have the spinner up here, right? 4 equal size sections labeled A, B, C, D. So let's say I spun this and I got A 3 times, B 5 times, C 4 times, and D once. So what is the experimental probability of getting an A? Well, let's see. I got 3 A's. How many spins were there? So we have 8 there, and another 4 spins is 12, and 1 is 13. So that probability would be 3 out of 13. The experimental probability for B, I got it 5 times out of the 13 rolls. C was 4 times out of 13 spins, and D was once out of the 13 spins. So again, I could use these to make predictions on how many I think I would get if I spun it 100 times. Okay? Let's say I wanted to look at A. Well, since it was 3 out of 13, I want to know about how many do I think out of 100. So I can set up this proportion. And when I cross multiply and solve this proportion, you'll see it's not going to come out even. I get 13x equals 300, and I'm going to divide by 13. And if I divide 300 by 13, it does not go in evenly. 13 goes into 30 2 times. 26 leaves me 4 left over. And then it goes into 43 times. That's 39. Leaves 1. And it doesn't go into 10. So I'd have a 0 there and have to bring another 1. It goes into 100 7 times. Gives me 91. So I see it's 23.07. So obviously, and then the decimal would keep going. Obviously, I'm not going to guess that in 100 spins that it's going to come out 23.07 A's. But I would say it's probably going to be about 23, right? So when it doesn't go in evenly, like on the last page, all these, I did it out of 10, so I went to 100 evenly, so those are easy. If it doesn't go in evenly, that's okay. It doesn't have to go in evenly. I can still use it to make a prediction. I'll just go close to this. So I would guess 23. So experimental probability is what actually happens when I'm doing an experiment. Right? These are all the same size. Theoretically, they should each come up 1 out of every 4 spins. That's not actually going to happen. Now, the more and more times you spin, the closer and closer those probabilities should get to being the theoretical ones. When you have small amounts, like only 13 spins, they can be all over the place. Or only 10 rolls. They can be all over the place. But as I do roll more and more and more times, they should all get closer to being 1 out of 6. So that is experimental probability.